Okay, so we're looking at the exam style practice paper from the first year textbook, and we are on the last question, so question 15. Okay, so we have got a circle in its expanded form, and we need to show firstly that the point A does lie on the circle. Okay, so let's do that. So x squared plus y squared minus 4x plus 6y equals 12. Okay, so first thing I'll do is show that 5, 1 does lie on the circle. So if x is 5 and y is 1, does that equal 12? So they'll just want to see some kind of working out. So 25 plus 1 is 26. Minus 20, so I'll just show an intermediate stage of working and then just a conclusion. So therefore A does lie on the circle. Okay, so that was really just a little bit of a warm-up question, I think. Then they want the centre and radius of the circle, so that's a very common thing for us to ask for, and in fact, just write it out. So first thing I'm going to do is rearrange the order. So I'm going to bring the x squared and the x term together, the y squared and the y term together. I'm not really bothered about the 12. And then I'm going to complete the square on x squared. So that's going to be x minus 2 all squared minus 4. Then I'm going to complete the square on y squared, so that's going to be y plus 3 all squared minus 9. Then I'm going to take my constants over to the right hand side. So 12 plus 4 plus 9, and from that I can say that the centre is 2 minus 3, so the opposite signs of what's in the brackets, and the radius is the square root of 25. So the radius is, the radius is 5. Okay, right, question B. Find the equation of the tangent to the circle C at the point A, and then they want me to give an answer in that form. Okay, right, so I don't really need a particularly accurate sketch, but I'll just draw out so I can see what's going on. So the centre is at 2 minus 3, and the radius is 5, and A is at 5, 1. So it really doesn't matter if this is accurate, but I'll get it in roughly the right position. So I'm going to say 5, 1 is about there somewhere. Okay, and I want the equation to the tangent. So when they mention a tangent, that does make you think about differentiation, but we don't know how to differentiate the equation of a circle, so we can't be related to that. Instead, I want to use the fact that the radius and the tangent are perpendicular to each other, okay? Because I get the gradient of the radius, so change in y, so 1 minus 3 over change in x, so 5 minus 2, so 4/3, then the gradient of the tangent is going to be perpendicular to that, so the negative reciprocal of 4/3, so minus 3/4. Okay, so now I've got the gradient of that line. I know it goes through 5, 1, so I can use y minus y1 is m times x minus x1, so y minus 1 is the gradient times x minus 5. Okay, so that's just using the x and y coordinates of A. Okay, and then it did ask for it in a particular form. So it wants it in the form y equals ax plus b. So I'm just going to multiply out the brackets on the right-hand side. So minus 3/4 times minus 5 will be plus 15 over 4. And then I'm just going to add the 1 over. So 1 is 4 over 4. So that will become 19 over 4. And that's in the form that they want.